Welcome back to the channel. So as these Foxbody Mustangs start to age, the computers in them start to get increasingly problematic. They have failed solid state components, most notably leaky capacitors, and because Motes is out of business, the chip systems that allow us to program these cars are becoming increasingly difficult to get a hold of. And that kind of leaves us with one option, which is to put a standalone engine management system in the cars. Now there are a few options out there. Holley Terminator X is a good choice. I've seen guys who got carb versions or carb conversion Foxbodies that use Sniper. There's a Pro M system that sometimes guys use, quite unusual. And there's Megasquirt. Megasquirt comes in a bunch of different flavors. There's a Pimp X version, there's a do-it-yourself version, and so on. But there is a Megasquirt plug-and-play system specifically for these cars. It's designed to work with these cars, and it is probably the least fuss way to put an aftermarket engine management system in your Foxbody. This little car has a nice little naturally aspirated build on it. It's got some SVO heads, and it's got a real Edelbrock Performer RPM manifold, not the Pro Products knockoff. It only has stock injectors, which makes me a little bit nervous. It's supposed to have a fuel pump upgrade. The car looks in very nice shape, and the guy who has the car has had it for quite a while. And most importantly, the wiring harness in the car doesn't look too bad. If you have one of these cars with a good wiring harness in it, Megasquirt 2 plug and play is really not a bad option to go for. It's going to reuse all of your factory sensors and actuators. It's going to plug straight into the factory harness, and it does provide some additional features, although it doesn't provide support for any of your emissions features if you're somewhere where that's important. And really, all you have to do is run one extra vacuum line into the cab. That computer is going to sit in the same spot that the factory computer sits in, and it has the advantage of being brand new electronics that are not leaky or failing. It's user programmable, so we can just plug a laptop into it and program it. We don't need anything special, and especially we don't need something like a quarter horse, which is now discontinued. This customer figures he's going to move up to a supercharger at some point, so he wants the car to be more programmable. He wants a longer term solution. He plans on keeping the car. So what we're going to do today is put an MS2 plug and play in. I don't think I'm going to show you all the details of how to program the Megasquirt, but we're going to go through all of the physical steps to installing it and getting it to work. The first thing I noticed when the car came in is it has a check engine light on. So while we don't really care about the emissions equipment, that check engine's often for that, it may have a problem with an oxygen sensor, and Megasquirt 2 plug and play only uses one oxygen sensor anyway, so it'd be helpful for us to know what was wrong with the car before we started, so we can avoid, say, hooking a bad oxygen sensor up to the car. So I've got my Ford code reader hooked up here. I'm just going to perform a key on engine off test, and we'll see what codes are on the car, what it thinks is wrong with it before we started. Flick that over to test. It's going to interrogate everything. Six. Then if I set this to hold, it should clear the codes. We'll shut the car off. But the reason to do this is we're going to reuse everything in the harness and sensor package on the car. So if something was wrong with it, we should try to figure out what that was so that we can resolve it if we need to, or avoid that problem as we go forward with the Megasquirt. We got 34, and this was both historical and current. Insufficient EGR flow or EVP voltage high. That's EGR. We're not going to care about this anyway, because Megasquirt isn't going to run that. But I can see the EGR valve does not have a vacuum signal hooked up to it. So that's why we would be getting that code. More than likely, the way this is done is with block off plates, so there's probably no EGR flow through the car at all, and they disconnected the vacuum line from the EGR valve. So that's why we'd get code 34. That's not a problem going forward. We're not going to care about that. The next code is 63. Throttle position circuit fault below minimum voltage. So that could be a problem. We could have a throttle position sensor fault here. We're going to have to look more carefully at that. Let's see if it's plugged in. It might be a bad sensor. Might be, it looks like it's plugged in here anyway. It might be something in the circuit. Now we are going to care about the throttle position sensor, so I think we had better investigate that a little bit further before we get too far down the line here. And the next code was 85. This is canister purge solenoid circuit failure. Well, I can tell you the car doesn't even have the charcoal canister on it, so that's no surprise. I don't think we're concerned about that, but we are concerned about the throttle position sensor. So let's try and get a little diagnostic of that and figure out if we're dealing with a bad throttle position sensor and if we need to do something about replacing that or fixing that circuit. We got to check what's going on with this throttle position sensor, because we definitely need that for Megasquirt. Normally when I'm programming these cars, I'm just going to plug my quarter horse setup in with my laptop, and I'm going to read what the computer sees the throttle position sensor as, and that's going to tell me whether that sensor's working or it's bad, out of range or whatever. But this car, we don't really even intend to put a chip on it or anything. We're going to switch it out for the Megasquirt. The Megasquirt still needs a throttle position sensor, so I'm going to show you a little old school trick, and this is something that you guys can do yourselves. This little device here is something that I made years ago out of the junkyard. This end here is cut off of the body harness on a Mustang, and this end here is cut off of the throttle position sensor on a Mustang. Then they're just spliced together with butt connectors, and the green and black are left with a bare spot that I can clip onto with alligator clips. That allows me to just plug this unit in line with the throttle position sensor wiring, clip my multimeter here onto it, and check what the readings are from the throttle position sensor. The reason for this is so you don't have to back probe the wiring on the throttle position sensor harness, and also you don't have to remember it's the black and green wires. They're always bare and the right wires. Constantly back probing these harnesses pokes a hole in the insulation. You can get moisture in there and it can corrode the wiring inside, and that can lead to problems down the line. And in fact, often that's the problem you have with your throttle position sensor, because somebody already did this to it some time ago and now it's all corroded in there. All we do is unplug the throttle position sensor, and we're going to look in there and see if, for instance, we've doubled up on the weather pack. Sometimes that's a problem. Doesn't look like it. Then we're going to take this unit and we'll plug one end of it into the body. The other end of it into the actual TPS. Then we're going to take our alligator clips and we're going to clip those to the bared wires. We'll turn our multimeter on. We'll key the car to run. And we have 0.6 volts. That doesn't look right. Let's press this in and see what happens. Okay, that goes up to about 4.2 volts. So this reading here is really low. It shouldn't be this low. It actually won't matter for Megasquirt because there's a separate throttle position calibration, but that would be wrong for the actual Mustang computer. One of the things we should look for is we should push this in gently and see if there's any dead spots. There isn't. It looks okay. So, although this isn't right for the Mustang, it does look like the sensor works, and we're going to be able to set these voltage values as the minimum and maximum throttle position in Megasquirt, so we don't have to make any adjustments. I think we can work with that. If this is really a Mustang computer, we kind of want this value to be somewhere below a volt and at least somewhere above 0.8 volts. Usually I try to shoot for like 0.92, something like that. The way that's done is to actually turn the throttle position sensor on there. It's not really designed to be turned, but it can be, and sometimes you have to slot the housing in order to get it in the right position. This is an aftermarket throttle, a Holley throttle. Who knows exactly why it reads so low, but this would have been a problem with the factory engine management, and it is a problem. That's why it's setting codes, but it should not be a problem with our Megasquirt. So we're going to say that all the stuff that looks like it's wrong with the car according to the factory computer is emissions, which we don't care about because Megasquirt doesn't support emissions and Alberta doesn't have emissions laws. And the throttle position sensor, which looks like it works correctly, it's just out of range for the factory computer, but not out of range for the Megasquirt. So with that said, we're going to say we're ready to unbox the Megasquirt, and we're ready to start tearing into this car to replace it, replace the engine management system with the Megasquirt. All right, so there's a Megasquirt 2 plug and play in this little box here. Let's open it up and see what we got. I cut it open to make sure this stuff was here, but there we go. My ECU birth certificate. What we got in here, besides a birth certificate, is a length of vacuum hose, sticker for an MS3 Pro, an ECU. The ECU here is the exact same format as the factory ECU. It's in the same dimensional box, and it's got the Ford 60-pin connector on it. That's what makes this a plug and play. I guess as a general warning, this stuff isn't emissions compliant. It's not legal in states where you've got to have all the emissions equipment. Alberta is not a place like that. It's not even in the United States, so the EPA has no jurisdiction here, neither does CARB. So we're not worried about that for our application. We've got our 60-pin Ford connector, our vacuum port for the map. We've got another little port here, which I think is actually for the serial cable or USB cable, communications cable. And back here we got our option port where we can hook optional stuff up to the Megasquirt, which could include things like fan control. Now, it is a MS2PNP 2. What else is in here? Some jumpers, vacuum tee. We've got the components to make up the serial cable for the optional stuff on the back. I don't think we're going to use any optional stuff on this car. It does have an electric fan, but I had a little look through the electric fan setup, and frankly, that looks like its own project to get that wiring the way I would like it and hooked up to a Megasquirt. So I think we're going to leave it the way it is for now. This is the tuning cable. So you can see it's got a 9-pin serial connector on this end, and it's got that round port on the other end, which plugs in here so that you can plug your laptop into it. Then you'll need a USB to serial adapter. And there's a USB stick. Presumably it has Tuner Studio, and it may have a bass tune file for a Mustang on it, maybe. With an MS2 plug and play like this, you can just stick it right in the car and use it. But the one thing that I don't really like about this combo is it only uses one of your oxygen sensors. It'll use a factory oxygen sensor, and by default, it's going to use the passenger side bank 1 oxygen sensor. Now, in my experience on a 5-liter Ford, if one bank is going to run leaner than the other, it's going to be the driver's bank. So my philosophy always is to put wide bands or control sensors where there's only one on the driver's side whenever possible. That can be accomplished with the MS2 plug and play just by changing a jumper. So we're going to open the box up here to change that jumper. What you're going to need is a little Phillips screwdriver and I think a 3/16 socket, because in order to open it up you have to take these little screws off around the option connector because they go through the metal case. So let's start with those. Then we'll do the 4 screws on the sides. That's here and here. So that's the 4 screws, and then the cable retainer nuts. And we should be able to kind of lift this off and slide it back and off. Okay. And that opens up the system so you can get a look at it. All right, this is going to give you a little bit of a look inside here. There's all kinds of jumpers on here. Don't mess with these. These are not for you. But the one thing that we want to do is change the oxygen sensor setup. Now, if you read the manual, it identifies that as J6. That's not true. If you look here, this is J6, and this is a boost select setup. But you can see it clearly labeled on here. On this version of the MS2 plug and play, jumper J4 is the oxygen sensor select, and it's currently set to right sensor, so we want to change that to left sensor. I'm just going to use a little needle nose plier here and move that over. So I've just moved that from right to left, and that will allow me to read the driver's side oxygen sensor, which is the one I prefer for one of these cars. So that's the single change you need to make inside here, but it's nice to know what's in here. Now you can see here, this is the little connector for the map sensor. This is delicate. It's a real delicate little part. So you got to be careful when you're working around this in the car. And it goes over here to the board where there's a little map sensor on the board. That's what the inside of one of these looks like. Let's go ahead and put the case back on now that we've got our one jumper selection made, and we'll start prepping the car to put it in. The first and one of the most important steps is to disconnect the battery. Don't leave this hooked up or you're going to be really sorry. Another thing to watch out for is some of these cars are going to have a big capacitor in them for a stereo or something like that. I always check that all electrical functions are terminated before I begin. A good way to do this, I guess, is look for interior lights and whatnot when you open the doors. But just make sure that your battery and your power is all disconnected. Our next step here is to get the PCM out. It's in here in the passenger side kick panel. This can be a miserable place to work, but it's usually not that bad. So step one is we're going to take one screw out of this sill plate. You need a little Phillips screwdriver for that. Take that out, just set it on the floor there. Then we can kind of pull the sill plate away and pull this kick panel out. We'll look to see if there is a press-in button on here, or a retainer tab. There is on this one. A lot of these cars have been molested pretty hard and they don't have this. I find the easiest way to get this out is just kind of reach in behind and pull back on the whole panel. I mean, this has been out at some point. Then we're going to take this. There are retainers in here that press into the body of the car, and it's going to slide out from underneath this A-pillar trim. So we're going to kind of pull it down and back, and of course on this one the retainers are completely missing. So somebody's been in here more than once. This car's not, you know, unmolested. None of them really are. I usually throw that in behind the passenger seat. Now we've got all of our kick panel wiring and stuff exposed here. The PCM is tucked up in here. And let's kind of pull this harness out and see what the heck we got going here. Oh my. This has got some kind of a piggyback unit installed here. Now, This is going to be kind of unusual having a piggyback unit like this installed. I'm not quite sure which one it is, but it makes life a little extra hard because we need to get the PCM kind of pulled out far enough here that we can get at the 10 millimeter screw on the back here. This is a piece of the PCM retainer. It would normally be attached in a factory setup. It would be attached with a 7 millimeter headed screw into the kick panel area here and hold the PCM in place. This has got this extended deal on here. Let's see how we do at getting this pulled out and away. Kind of push it up a little bit first. Every one of these cars is its own adventure. We got to try and avoid damaging this wiring harness while we're working on this. I finally got all of this stuff out of the kick panel. It was a real struggle because not only did it have this breakout adapter on here with fully exposed pins, which could have been shorting to something and causing problems, but it also had one of these old super chips on the end of the PCM. And then this stuff's all secured with this extra long bolt, which of course threaded out of the PCM and wouldn't allow me to disconnect the wiring harness. What a mess. With this on the end, I couldn't push the PCM up enough to get enough clearance to pull the wiring harness away. But anyway, I finally did. It's a real dog's breakfast of stuff and could have been causing problems like with this open breakout box. All right, now we have all of this old PCM and stuff out of the way here. Here's all we have to do. Just basically connect our Megasquirt to our factory harness. Now, ultimately, we're going to have this put up in there. Usually, when I work on this kind of stuff, I like to leave the PCM out on the floor initially. It's not a big deal to change it around afterwards. So, let's start by connecting our serial harness up. The older Megasquirts, there was a connector on the back here. On these ones, goes like this. It's keyed. It's a keyed connector. Tighten it down. We'll take our factory harness there. You want to try and be gentle with this in case something has gone wrong, especially since this harness has been plugged into kind of a nightmare and then kind of dragged on. But we're just going to tighten this down, and what we're looking for is when it's actually tightened down, this little stop should actually rest against the connector. That's all the way tightened down. You'll find it'll get hard with the hand tool there, or the hand ratchet, thumb ratchet, but by now we're pretty sure that we're seating properly, so we can finish it up with the ratchet. Now you don't want to go too tight here, just get that snugged up against there like that. If you crank on this too much, you can actually pull the screw right out of the connector, and that causes you problems down the road. But that's all hooked up. Then we can plug our computer in here, and then all we really need is our vacuum line to go into here. So let's start seeing about fishing that through. Now, the one major thing we've got to route from the engine bay into the cab for Megasquirt 2 plug and play to work is a vacuum line. So I started looking for how to do this. Now, normally we will route the vacuum line through this grommet down here, which is for the engine management harness. We've got this catch can in the way, so I'm going to take that off, at least off the firewall here, so we get a little more room to work. And then, of course, the car didn't have Thermact or any of that anyway, but it's got all this wiring or all this vacuum set up here. I can see most of this stuff is wrong. If you look, here's one of the common problems on these cars. Someone has hooked a vacuum line up to the map sensor. That's wrong. And this should be hooked up for HVAC. This line here goes in to your air blend door inside the cab. There's nothing hooked up to that, so the air blend door and stuff probably doesn't work. And I'm pretty sure, if I remember right, this is supposed to go down to a pot down in the inner fender there. I see the line for it down in there. I don't know if I can show you where it is. Yeah, you can just kind of see that line poking out down in there. But that's not hooked up. So there's a whole bunch of vacuum routing issues. Because we don't have any of this Thermactor stuff, what I've decided to do is I'm going to pull this one here, which is on the back of the manifold, off. And I'm going to use that as my vacuum source for the Megasquirt. If it wasn't quite clear, here's what we're trying to do. We're going to run a vacuum line from the manifold through the PCM harness grommet into the kick panel area and then hook it up to the PCM. In order to do that on this car, we're going to move this catch can out of the way, and I have selected a vacuum location on the back of the manifold that was being used by something that wasn't hooked up right and is no longer needed or wasn't needed on the car. So we're going to run that vacuum line from the back of the manifold back down here. Now, ideally, the PCM has its own separate vacuum source. That's going to be the fuel control. So what you don't want to do is have that teed into 50 other things, and then when something down the line fails or gets a leak, now your fueling is screwed up. If there is any way, hook the PCM map sensor up to its own separate vacuum source. It's less problems down the line, it just works better. To pull the vacuum line into the cab, I first had to get the catch can out of the way. After that, I removed the tab-tad or Thermactor solenoids from the back of the passenger shock tower to clean up the area and make a little more room, since they're redundant with the Megasquirt. I then spent some time cleaning up vacuum lines from the Thermactor system and ones for the HVAC system that were disconnected or hooked up wrong. This car already had either a piece of redundant wiring or vacuum line that was run into the engine bay through the PCM grommet, so I taped my new line to that and used it to pull the new line through. If you don't have something like that in place, pull the PCM grommet into the engine bay, then carefully cut the PCM grommet from the side up to the cable bundle, then feed welding wire or something similar from the engine bay down into the cab, attach that to your new vacuum line, and pull it in that way. That's the physical install of the Megasquirt done on this car. I think sometimes when guys ask me to do this for them, they're a little surprised that I say I'm going to take a whole day on the install. But here's the thing, it should go easy. It never does. There's always some nonsense that you have to deal with on a car. And this car is no exception. Even though it seems like a pretty good car, it had a terribly unusual PCM configuration with a breakout box that extended the length of the PCM by that much, and then a super chips which extended the length of the PCM by that much, all jammed back in the inner fender, and it was very difficult to get apart without wrecking something. So that takes time. It also has a catch can that was in the way of running the vacuum line for the Megasquirt and so on. There's always stuff like that. So with the physical install done, what's left? Well, the software setup and the initial setup of the car is left. So let's hook our laptop up to the car and we'll go ahead and start working on that. At this stage, we've got to have power. So we're going to hook the battery back up as well. Okay, I think you can see we've got the Megasquirt installed here. We've got cable running from that over to the PC. And on the PC, we're using a serial to USB adapter. So I'm going to turn the key to on. Go ahead and start Tuner Studio. I'm not going to show you installing this. It comes on that USB key, or you can download it. We're going to create a new project. So we're going to name our project. Then we're going to say detect firmware. And it's going to automatically, hopefully, find our device. There it is. There's our Megasquirt. It's on COM4. Everything looks good, so we're going to accept that. Then we're going to go next. Oxygen sensor display. Well, this is actually a narrow band. I prefer it in Fahrenheit, etc. Most of this is okay otherwise. Okay, now it did a successful port test. That's important there. So everything looks good. We're going to say next. We can select our default dashboard. That's fine. And it's going to connect. The first couple things you're going to look at here are things like your temperatures and your barometric pressure, or your map sensor. So, okay, this is fuel load. I usually just change this to say map sensor, but either way, that's the current barometric pressure reading from the map sensor in kilopascals. Calgary is about 3,500 feet. Around 90 kilopascals is right on the money. Coolant temp 78, that's probably about what it is in the shop. I'm going to change this lost sync counter here to be manifold air temp. That's about 7980. So these should be about the same, and they are. That's a good sign. I'm going to change where it says fuel load here to map. It's the same thing, but whatever. Engine map. And we can see our throttle position is minus 13.4. That's because, if you remember, our throttle was set pretty low. So what we're going to do here is I'm going to go in and I'm going to calibrate my TPS. And first I'm going to get my current at this level. Then we need to press the throttle to the floor and get the current at the wide open throttle. So let me just do that from inside the cab here. So all we're going to do here is put our foot to the firewall. You'll see that value go up. I'm going to say get current there. And that came up as 889. Then I'm going to say accept. Okay, there's a couple other things you're going to typically want to do here. First and foremost is we're going to go into tools, calibrate AFR table, and we're going to set our ego sensor here to narrow band, because that's what we're actually using. And we're going to say write to controller. Usually these systems come configured for a wide band. If you don't do this and you're just plugging it in and using the factory oxygen sensor, it's never going to work right. So that's an important step. All right, and then what I like to do before we do anything is we're going to save tune as, and we're going to call this start. Then I'm going to save tune as again, and I'm going to call this Dyno 1. Now when we're making changes, we can always go back to wherever we started. So let's take a look at what our basic settings are here. Our engine settings, we're going to go into required fuel here. And our engine displacement is, let's put it in cubic inches, it's 306. Injector flow rate is actually 19 pounds per hour. and our air fuel ratio is 14.7, so we'll do that. I'm going to burn that to the controller, and it says it wants a power cycle for that, so let's do a power cycle. Let's check our Eagle control, narrow band, that's good. Controller authority, let's give it 10% to begin with. Let's make it active above 500 RPM. Flow map 80 for our elevation. Algorithm simple. That should be fine. And let's look at a fuel table and see what we got. Okay, well, we got some kind of fuel table here. Let's look at a timing table. All right, we got some kind of timing table there. That's probably enough to actually start the car. Now, once we do get the car running, we're going to want to go into our ignition settings here, and we're going to change this fixed advance to say fixed timing. We're going to put in a value like 20 degrees. So let's say we do it like this, we put in 20 degrees, then that should lock timing at 20 degrees. Then we'll use the timing light to check that we're actually at 20 degrees, adjust the distributor until we are, and then when we come back in here and set use table, whatever it says in the timing tables is going to be our ignition setting. So whatever's in here will be accurate. With any luck, we got enough to actually try and start the car. Let's see how we do. All right, well, here goes nothing. Let's see if we got enough to start the thing. I'm sure that's too rich. Well, we got a runner anyway. We should go ahead and set the timing on it. Okay, so to set the timing, first I'm going to go and set it to fixed timing on the Megasquirt. Then we'll check it with the timing light, and if we need to, we'll adjust the distributor. So now it's fixed at 20. It should show 20 on the balancer. And it doesn't, it's more like 30. So someone has got this timing really, really advanced. Now, one thing to note, you do not pull the spout connector in order to set timing with Megasquirt. So I backed the distributor. I've loosened off the distributor. Let's try and back this timing down a little bit. It's about where it should be. Okay, that looks about right. Let's give that a final tighten. Okay, it's the end of the day, and here's what we've accomplished. We've physically installed the Megasquirt. We have done the initial setup work on the Megasquirt. That means setting the timing, the distributor timing, and doing a little bit of software adjustment. Got the car started. Found a problem, which was that the driver's side oxygen sensor on this car is not working. There may be a harness problem. I looked in there, it looked like there might have been some melting on that harness, and the customer, in fairness, did say that he thought the driver's side oxygen sensor was bad. So I opened the Megasquirt up again, and for this application switched it back to passenger side. It's not the end of the world. It's a preference to put it on the driver's side, but if that's not working, the path of least resistance is to put it on the passenger side. I've been through and done a few setup things on it, and this car is basically ready to go on the dyno and get a real tune tomorrow. The Megasquirt install is probably the easiest aftermarket engine management system install that you can do on one of these cars. In reality, when you go ahead and do this kind of thing, there's always some gotchas. The car's been modified. There's some stuff that doesn't work. There's some stuff you end up fixing along the way, and so on. So the amount of time required to do this was really all day. It's, for all intents and purposes, it's the end of the day, and we're now at a stage where we could load the car on the dyno and hopefully have a successful day tomorrow. Any other engine management system you're going to install, like Terminator X, for instance, you're going to have to run a bunch of wiring harness. And with a Mustang like this, that probably means pulling the upper intake off so you can get at the injectors. It's a lot more work. And it's more money because there's more components, because you got to buy the wiring harness. So if you have a Foxbody you're just trying to keep running, or you're going to do some mods on, and you've got a fundamentally good car with a good wiring harness in it, MS2 Plug and Play is a pretty good approach. I use it in my Lincoln over there, works great for that. The Lincoln wasn't really programmable anyway, so it needed to have something, and the MS2 Plug and Play, even on the Mark 7, just plugs right in. You lose your cruise control, which didn't work in mine anyway, and then you have to ground one wire so your horn works. And it's about the same as doing it in the Mustang as far as the install is concerned. Thanks for watching. We'll get this car on the dyno tomorrow, get a final setup on it, and then we'll be on to the next project.